Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from the National Science Foundation and donations from listeners like you. Well, today we will cover the sixth and final region in our climate series as we talk about the weather and climate of the South Central United States. And a good many of you, I could see from our registration list, live in this part of the country. So this webinar should be of special interest to you folks out there. With us today is Louisiana State climatologist and New Orleans native Barry Keim, regional climatologist and CoCoRaHS's Louisiana State co-coordinator Luigi Romolo, and Alan Black, the newly appointed program manager for the Southern Climate's Impacts Planning Program. All three are located at the Southern Regional Climate Center at Louisiana State University in Baton Rouge, Louisiana. Welcome, gentlemen. It's great to have you with us today.
Hey, thanks a lot. We are going to go ahead and switch to our screen here.
And I think we have CoCoRaHS Director Nolan Duskin on the line with us, too. Are you there, Nolan?
I am listening in for certain.
Great. Nolan will probably have a question for you, too, at the end. All right, Barry, take it away.
Okay, so screen's all working okay?
Looks great.
Okay, so we're going to talk about the climate of the South Central United States, which we're calling a hotspot for extreme events, and it truly is. I know the Southern Regional Headquarters for the Weather Service, brags, if you will, in quotes, that there's more severe weather in this region than virtually anywhere. So just a couple of background slides here. This is the average annual temperature across our region. You can see it ranges from about 74 degrees down in South Texas on up into the mid-50s in the extreme corners of our region. But the thing I really want to point out here is that we are looking at a north-south gradient in temperature, which makes perfect sense given the way the Earth is heated and so on. However, this is the average annual precipitation. Kind of takes on a different take here, where in the eastern half of our region, there's not a lot of gradient, but once we get into Oklahoma and Texas, you can see a very steep precipitation gradient going from roughly 60 inches in southeastern Texas all the way down to 10 inches over in El Paso. And that gradient across eastern Texas in particular is really, really dramatic. So this is some work I did with Jill Trepanier and one of my master students, Michael Roberts, where we looked at dry spells, and I put this up here to you CoCoRaHS observers because I know it's not fun logging zeros in your data set, but zeros do matter. And what this shows is the longest dry spell at each of those stations across our region. And if you look at, most of our, and this is from 1950 to 2013, just for your information. And you can see across most of the eastern United States, or the eastern part of the region, I should say, the eastern half, 30s, 40s, and 50s are pretty common. Once we get into Texas and Oklahoma, though, those numbers jump quickly into the 80s and 90s. And as you look, I'm going to point this out over here. We have a site here. I believe this is Val Maria, if I'm not mistaken, went 194 straight days with no rain. So zeros matter, and we certainly appreciate you guys logging all that information. So I'm going to spend a chunk of time looking at the August 2016 Louisiana flood event. Unfortunately, it has no name. I have a few suggestions, like the no-name storm that ripped Louisiana. I kind of like that. It has some pizzazz to it. Tropical wave Boudreaux to Cajuanize it some, or maybe tropical disturbance Lagniappe. Lagniappe is a New Orleans term. It means a little something extra, and this storm certainly gave us a lot extra in terms of rainfall and flooding across our region. So I'm going to walk through this kind of synoptically, if you will. I'm going to go through this pretty quickly. Looking at this map, this is August 2nd. Now keep in mind, most of the heavy rain started here on August the 11th. But this is the first map where there's no semblance of the storm. But I want you to take notice of where this H is located, right off the coast of Florida. Here we go to the third. Basically in that same location, you can see a little trough that's put here. I would call this a tropical wave or an easterly wave. And if you notice on the right-hand side, this is kind of the progression going from a cluster of thunderstorms to a wave. Waves develop, turn into tropical depressions. Depressions further develop into tropical storms, which can form into hurricanes. So really, this is This is like a precursor to a hurricane, except it never really develops. It just stays a tropical wave. And so this is on August 3rd, and I just kind of watched this thing move around the Florida coast, and eventually it drifts on into Louisiana. So we're here on the 4th, the 5th, the 6th, 7th, 8th. Here, actually, it's over Pensacola, the little trough symbol. We're starting to develop a little bit of low pressure around the region, and I would actually call this a tropical depression in this particular stage here, although I don't think the Hurricane Center ever actually called it that, but it certainly appears to be one to me. This is on the 9th, this is on the 10th, and this is August 11th. This is 7 o'clock in the morning on August 11th, and this is when some of the heavy rains really started in Louisiana. And I note, while this thing was dancing around over here in Florida and Alabama and so on, it produced rainfalls. I can't remember the totals specifically, but I'd say anywhere from 2, 3, 4, 5 inch kind of totals across much of the region. So this thing was producing some pretty serious rain, but nothing like was up and coming in Louisiana. On August 11th, I'm sitting at home with my family watching the Olympics, like a lot of other families around the country, cheering on our athletes. And but thunderstorms started that evening, and it rained all evening. It rained all night long. I woke up the next morning on Friday. It was still raining. I checked the data from the Baton Rouge airport. It literally had rained every single hour overnight. It literally rained every waking moment of Friday. And so it was raining when I woke up. It was raining when I went to bed. It never stopped. It rained overnight that night, and it was still raining into Saturday morning. We ended up with 2 straight. We ended up with 32 straight hours of precipitation, of measurable precipitation, and 39 straight hours of with at least a trace of rainfall. Here we are on the day when most of the rain actually fell. The low pressure is located, just right here in Mississippi and parts of Louisiana, just north of Baton Rouge. The storms to our west were actually moving from north to south, going around the area of low pressure. The storms on the cells on the to our east were going from south to north as it kind of wrapped around this area of low pressure. But what was really interesting about this event is it just never stopped raining. It was just a steady rain, and no particular hour was overly excessive, but it just never stopped, and it just kept coming and coming and coming. And so here we are moving into the 13th. There had more rain in southwest Louisiana on this day, and then eventually gets absorbed on Sunday the 14th into that frontal system and into Monday. And it wrapped a lot of tropical moisture into this extratropical system, and they got some pretty decent rains in Texas out of this as well. Again, nothing like what we had, but 2, 3, 4, 5 inch kind of totals were very common. This is the footprint of the rain in this area, this magenta color. As you can see, this is all 10 inches or more, and then when you move to the purple color, that's 15 inches or higher, and then the white embedded inside is 20 inches or more. And we had really 2 centers of gravity. One is over here by Baton Rouge, and then this is down closer to Lafayette and New Iberia. And so 20 inches or more in those areas, and it's no wonder that we had the severe flooding that ensued across our region. To put some of the rainfall totals in perspective, okay, this is 2-day rainfall totals for the 100 and 1,000 year return frequencies. And from NOAA Atlas 14, a 100-year event for, say, Baton Rouge and its general vicinity is about 14.2 inches. A 1,000-year event comes in at 21.3 inches. Now, these 4 sites here, these are all CoCoRaHS gauges, I note, and these were the 4 highest rain totals that we had in Louisiana over a 2-day period. And as you can see, we grossly exceeded the 1,000-year event. Over here at Watson, we had 31.39 inches of rain. And to put some perspective on that, it's more than double the amount of rain you would expect in a 100-year event, and it's still a full 10 inches over the 1,000-year rain event, as denoted by NOAA Atlas 14. So it was just an amazing event. And if you notice this little note on the bottom, the previous record high 2-day rainfall total in Louisiana was 24.46 inches at Abita Springs, and that was measured on May 9th and 10th, 1995. So we shattered that previous record, and we had 3 sites in the state that actually broke it. This is a more comprehensive posting of the rain totals around the region. And this first column here, column is the location. The second column are the 2-day rain totals in comparison to the 100-year and 1,000-year estimates from NOAA Atlas 14. I just highlight some of these. Livingston and Norwood, both over between 21 and 22 inches, both greater than a 1,000-year event. Lafayette and New Iberia, both hitting around 21 to 22 inches as well. But But note that the 100-year event is pitched a little higher, 15.7, and the 1,000-year at 24.8 is also pitched higher because historically they've had heavier rains in the southwestern part of the state. So these events come in at greater than a 200 and greater than a 500-year event. Then this kind of cache of stations at the bottom, these are all CoCoRaHS stations. And if you note that we have a number of stations all over 21 inches, all greater than a 1,000-year event. We had in total 9 stations greater than a 1,000-year event. We had 11 stations greater than 20 inches over 2 days. And if you take it out to 3, 4, 5 days, obviously these numbers continue to go up because we were getting rain on both the front end and the back end of the heaviest concentration of rainfall. These are just a few pictures from around Baton Rouge. This is just on the north side of campus. This is a neighborhood, got a lot of student apartments, and clearly this street's clearly underwater. This is on the east side of campus, one of the main entries to campus from I-10, Interstate 10, and we had cars, obviously cars stalled, and in some cases maybe even floating. This is one of our little local eateries, Louis Cafe. Water never actually got into the building, but it sure got close. This is a raft of ants. I've worked a little bit with an ant expert here, and I learned how ants actually have this survival mechanism where when they get inundated like this, they band together and form a raft and actually float out of harm's way. And that's exactly what happened with this little raft of ants. You can see it's a relatively small raft, but this it stretched a couple of 2 or 3 inches across, and it was about 2.5 inches high, and it's just solid ants in here. I mean, it's just pretty amazing. And just some of the other work that we've done, hurricane risk is a big deal across our region, but elsewhere as well. This is a paper I published about 10 years ago with Bob Muller and Greg Stone. And what we're looking at here is the return frequencies of all tropical storms and hurricanes combined in the inner swath. And you can see any given location gets hit based on our model about once every 3 to 4 years across most of the Gulf Coast. It's about 5 years down here in South Texas, 3 years over here in South Florida. But notice it drops over here by the Outer Banks of North Carolina to every 2 years. So this is the most active spot tropically anywhere along our east and Gulf Coast of the United States for tropical activity. The middle swath represents all hurricane, the return periods for all hurricanes. And you can see along our north central Gulf Coast about once every 8 to 10 years. The numbers start bopping around a little bit. 12 years down here in Texas, 4 to 5 years here in South Florida, and once every 5 to 8 years over here by the Outer Banks of North Carolina. But where there's a real interesting geography is with extreme hurricanes category 3, 4, and 5. And so the major hurricanes are depicted in that swath well once every 20 to 30 years. The numbers really jump around here because our sample sizes are so small. But one of the things that's interesting is this Big Bend area of Florida through here. Notice these 105 pluses. Well, 105 means it's been struck once by a major hurricane in a 105-year record. 105 plus means it hasn't been struck at all by a major hurricane. And so that's kind of conspicuous to have this in the Big Bend area of Florida. It's real, and I mean there are some explanations for that. Major hurricane activity is about once every 15 years down here in South Florida. But once you get up here to Daytona, I think it's Cocoa Beach. I'm sorry, number 23. Notice that we're looking at 105 pluses almost exclusively, with one exception with 105 at Jacksonville, all the way on up through the Georgia coast. So major hurricanes are not common in this concave part of the coastline here from northern Florida on up through Georgia. I think that was certainly a big surprise to me in our findings. And if I'm a hotel developer and I'm worried about storm surge, major storm surge is one of my primary risks, it makes a whole lot more sense to build up in Jacksonville than it does down in South Beach. Just one last thing in terms of my section, I wanted to put a plug in for our SurgeDat database. If anybody has needs with storm surge, they can certainly contact me. We built the world's most comprehensive storm surge database. We have a public face right now. You can just Google that, and we have one website, but we have one that we're further developing that's more sophisticated, has more data, that is password protected. I'd be glad to make that available to whoever needs it while we continue to beta test. And this is a joint venture, I might add, between LSU and the University of Oklahoma through our SCIP program, which is funded by NOAA. It's one of the NOAA RESAs, the Southern Climate Impacts Planning Program. And just one of the cool things you can do with this is the top 10 highest surges along the U.S. Gulf Coast. We were able to put this together with this database, and you can see that you know, our specific region, the Mississippi, Louisiana, Texas coast, very well represented in this top 10 surges along the U.S. Gulf Coast, with 8 of the top 10 surges occurring in our region, and only 2 of them actually over in Florida. And of course, the top 2 have occurred at Pass Christian, Mississippi, 28 feet with Hurricane Katrina, 24.6 feet with Hurricane Camille. Both right, I mean, it has a lot to do with the bathymetry offshore right there by Mississippi, as well as the shape of Bay St. Louis, and the water really just kind of funneled and double funneled into this one particular area, creating those really catastrophic surge levels in that particular area. So I'm going to go ahead and pass the torch now over to Luigi, and he's going to talk about tornadoes in our region.
Good morning, good afternoon. Thank you, everybody, for making the call. I'm Luigi Romolo, the regional climatologist at the SRCC. I'm going to be talking about tornadoes in the southern region. So I'm going to talk a little bit at first about some background on tornadoes. I'm then going to discuss where tornadoes occur, how frequently they are in our region, and then I'm going to conclude my talk by discussing 3 specific tornadic events, the first of which is the 2011 super outbreak in April of 2011, the Moore, Oklahoma super twister of May 2013, and then I'm going to conclude my talk by talking about the southern Louisiana tornadic outbreak in February of this year. For those of you who aren't familiar with the term outbreak, it is a loosely defined term in meteorology that refers to a cluster of tornadoes that occur over a given region. All right, so to define a tornado, I like to use this definition: a violently rotating column of air that has made contact with the ground. Tornadoes come in all shapes and sizes. Over here, we can see a cylindrical shaped tornado. To the bottom right here, we see the more classic conic shaped tornado. They are also come in forms of ropey-like tornadoes that appear like dangling strings from the clouds. Tornadoes are very destructive. What separates tornadoes from other weather hazards in our region or across the country really is not its destructive force. We have other destructive weather hazards like hurricanes, for example. But one thing that separates tornadoes from other weather hazards are that they can occur with little to no warning. So that makes them very dangerous. Another is that they can cause damage on a very localized level. So up here we see an image of a tornado path that cuts through a part of the world. It's not unusual for a tornado to pass through your neighborhood, maybe take out houses just a couple of blocks away and leave your home with little to no damage. Tornadoes form in cumuliform clouds. They're not always visible as a funnel cloud. Cumuliform clouds, essentially cumulonimbus or thunderstorm clouds. They're also associated with an extreme pressure gradient difference from the surrounding air, typically about 10% lower than the surrounding air. That doesn't seem like a lot, but believe me, it is significant and it could cause this kind of damage. All right, I'd like to dispel some tornado myths. The second and third one on this list I'd like you to pay close attention to because they're going to come up later in my talk. The first one, highway overpasses are a safe place to shelter. The reason I included this is there's a YouTube video that is very popular where a family is driving down the highway. They're being chased down by what looks like a significant sized tornado. I'm not sure exactly what the rating of that tornado was, but at the last minute, they have no choice but to hide underneath a highway overpass. The tornado literally passes right over them, and they escape unharmed. Now, tornadoes can produce winds, as we'll learn, in excess of 200 miles per hour. Those are winds strong enough to destroy highway overpasses. So unless it's a last resort, as it was in that video, I would not suggest hiding under a highway overpass. The second myth, tornadoes are attracted to trailer parks. This is simply not true. Tornadoes do not discriminate where they make touchdown. They do like nice flat surfaces with little surface friction. They do tend to occur outside of city centers more than they do within city centers. Trailer parks are usually located on the outskirts of cities. Another reason that trailer parks get decimated in tornadoes is that they have little to no foundation. They're also not very sturdy. So it doesn't take a strong tornado to take down a trailer park, and the tornado doesn't necessarily need to go over the trailer park to destroy it. This brings us to our next myth. Tornadoes never hit large cities. Simply not true. St. Louis has been hit 4 times in the last century. Dallas has been hit. Oklahoma City has been hit numerous times. In fact, I could probably give a talk on just the tornadoes that have hit large cities. The second last on the list is something that probably everybody has heard about. Opening all your windows will reduce damage to your home. There's a belief that if you open the windows and the doors, that you will equalize the pressure between your home and the outside air. Not true. All you're doing is reducing the time it would take for you to get you and your family out of harm's way. Another weird tornado myth that has come up with students that have asked me in the classroom is that tornadoes always seem to precede hail. Simply not true. Tornadoes can precede hail, they can follow hail, they can occur during hail, and in fact, hail doesn't even need to be present in order for a tornado to occur. How are tornadoes classified? We have what's called the Enhanced Fujita Scale. This is an upgrade from the original Fujita Scale. This enhanced scale was adopted in February of 2007, and there are 6 categories that range from EF0, which is the weakest tornado at 65 to 85 miles per hour, and then increasing dramatically all the way to the strongest tornado, EF5, which has winds in excess of 200 miles per hour. So I mentioned that tornadoes occur during thunderstorms. Not all thunderstorms produce tornadoes. In fact, very few thunderstorms produce tornadoes. And to add to that, even the most destructive thunderstorms, the supercell thunderstorms, typically only produce tornadoes about 25% of the time. So what do you need to produce a strong thunderstorm? Well, you need fuel, water vapor. You need cold air aloft, and you need warm, moist, unstable air near the surface. You also need some type of mechanism that's going to lift the air to produce these tall vertical clouds, a cold front, or extreme surface heating. These are the kinds of things that will help produce the cumulonimbus clouds from which the tornadoes will form. All right, so where do they occur? On this map, I'm showing 2 tornado-prone regions. In red, you see Tornado Alley, and in blue, the lesser-known Dixie Alley. The boundaries for these alleys are loosely defined. Excuse me. They may vary from person to person. Some might include Missouri and Illinois. Some might go further north into the Dakotas and Minnesota, or include more of southern Texas. But for the purpose of this talk, I think these are pretty good approximations. So why here? Why not the West Coast? Why not the East Coast? The reason is that these are collision zones. What's colliding? Cold, dry air from the north with warm, moist air from the south. They collide in these regions, and that's where you get the most intense thunderstorms. In Tornado Alley, the peak of the season for tornadoes is typically in spring and early summer. Why then? And that's because the difference in the temperature between this cold air that's moving this way and this warm air that's moving into the United States, the difference between those 2 temperatures is at a maximum during that time. Now, one thing that separates Dixie Alley here in the blue from Tornado Alley is that there's actually a second peak in the tornado season in fall. And in fact, Louisiana and Mississippi, they get almost just as much tornadoes in the fall as they do in the spring. All right, so how frequent are tornadoes? Well, they've occurred in every state, including Alaska and Hawaii. Alaska has had, I think, 4 tornadoes since 1950. Hawaii averages little less than 1 per year. When looking at the lower 48, however, Texas has 140 tornadoes annually, whereas Oklahoma 56, Arkansas 32, Louisiana 37, and Mississippi 43. So that covers our southern region right in here. Now, this number for 140 in Texas is a little misleading. In fact, most of the tornadoes in Texas occur north of this line that I'm drawing from this corner of the Texas-New Mexico border across to about Corpus Christi. Everything pretty much usually occurs in here. We do get tornadoes as far south as Victoria and as closer to El Paso, but most of the tornadoes occur in here. When you calculate the average annual tornadoes per state by square mile, specifically by, say, 10,000 square miles, it's Oklahoma and Alabama and Illinois that really lead the country in tornadoes. So this number is a little misleading. It's mainly because the size of Texas is so big. When looking at the average annual fatalities by state, Arkansas has the most in our region at 5. Mississippi and Oklahoma and Texas have 4. Louisiana has 1. Leading the country is Alabama at 14, but that may be skewed by one of the events that I'm going to be talking about later, which is the super outbreak of 2011, where 250 people plus in Alabama died during that event. One thing to note, Louisiana here with 1 fatality out of 37 tornadoes, that's pretty good. It speaks volumes about how prepared we are here in our state, but it really speaks more about the fact that we don't get the severe tornadoes that they do here in Oklahoma or Illinois or Missouri or Arkansas or even northern Texas. It's very rare for Louisiana to get an EF3 or EF4 or higher tornado. All right, so let's talk about the super outbreak of 2011. This occurred over the days April 25th to the 28th. It was really over for the southern states by the 27th. It's difficult when assessing any weather hazard to call it a worst case scenario. And you could look at some events like the recent flood here in Louisiana or Hurricane Katrina or Hurricane Andrew. You almost can always say it could have been worse. Well, this was pretty close to a worst case scenario. We had 362 confirmed tornadoes. Most of those occurred on one day. There were just over 300 fatalities. Again, most of those occurred on one day. This outbreak covered 1 states from Texas to New York, caused over $11 billion in damage and 68 fatalities in the south. So let's have a look at the storm report maps. What you're looking at here are storm report maps from the Storm Prediction Center, and the little red dots represent tornadoes. On the right here, I have the storm counts for the entire event, and I also have the storm counts for each day in total. So on April the 25th, there were 42 tornadoes. On the 26th, there were 55. On the 27th, 218. And on the 28th, there were 47. And you'll notice that there's a linear pattern here on those first 3 days. This was because this was driven by a very strong cold front that was located approximately right here. In fact, there were only 4 deaths on this particular day. As the cold front moved further south into central Mississippi and northern Louisiana, the storm count increased a little bit, but there were actually no fatalities on this day. The 27th was really the heyday for this event, in which 317 people died. There were 218 tornadoes, including 1 in Tuscaloosa. So again, dispelling the myth that tornadoes don't occur in large cities or cities at all. And by the 28th, everything was pretty much out of the southern region and moved on to the northeast. Just looking at some of the damage that occurred, I know you're probably all familiar with aerial photographs of tornadic events and seeing large-scale devastation, but you rarely get to see close-ups of the kind of damage that a tornado can produce. And I thought this particular photograph was quite telling. It was taken by, I believe, the Weather Service office in Jackson, Mississippi. This is a car that got blown up against a tree stand, hardly recognizable, lots and lots of damage, bending, twisting of metal. This is the kind of destructive force that an EF5, or the strongest of the tornadoes, can produce. Also wanted to include this particular photo. I think you're all familiar with the story of the three little pigs. They build a house out of straw, the wolf blows it down. They get wise and build a house out of wood, the wolf blows it down. Then they excuse me, they then build a house out of brick, and the wolf is out of luck. Not with the case of a tornado, however. This was an EF3, EF4, very capable of bringing down brick homes. And I also wanted to point out this tree in the background here that got stripped down with its bark totally stripped out. And this is because when tornadoes make contact with the ground, they pick up debris. That debris then spins around the tornado, moves pretty much at the speed of the tornadic winds, so they become bullets and start grinding away at everything that they encounter. That produces more debris, which increases its ability to destroy and take things down that are in its way. So again, a very destructive force. The Moore, Oklahoma super twister, and I titled this, "It Doesn't Take an Outbreak to Cause Devastation. Sometimes it just takes one tornado." And this was one heck of a tornado. It was an EF5 tornado with estimated wind speeds of 210 miles per hour. What's really astounding about this tornado is that it was on the ground for 47 minutes, cut out a 17-mile track, and at its peak was 1.3 miles wide. If you look at the statistics of tornadoes, this is an incredible storm. 24 fatalities, 221 injuries, and over $2 billion in damage, including the destruction of over 1,000 homes. I mean, these are hurricane numbers, these last 2 points. This is incredible. This was just Moore, Oklahoma, which I might add is part of the Oklahoma City metropolitan area. All right, so let's look at some damage photos. This is a subdivision here in Moore, Oklahoma, and usually a tornado will pretty much take up maybe 2 blocks or 3 blocks, but this goes on forever. And as you see, the houses are stripped down to their foundation. But look out into the distance. You see here, houses are standing just fine. So even with an EF5, localized damage, the localized damage is larger because of the larger scale of the storm. But over here, you can see houses still standing, houses destroyed, just a few thousand feet away. This was Briarwood Elementary School in Moore, Oklahoma. This storm bubbled up out of nowhere. They were expecting severe weather. They had had severe weather in Oklahoma the day before. At about 1 o'clock, the National Weather Service had issued a tornado watch. That alerted the news stations. They went to wall-to-wall coverage. Schools were let out, which was fortunate because the tornado actually touched down at around 2:46 p.m., right about the time when kids are getting out of school. And if you've ever picked up your kids from school, you know it's a traffic havoc. There's cars everywhere. Not the kind of situation that you want to be in when a tornado comes through, and especially not the kind of situation you want to be in when an EF5 moves through. So kudos to the National Weather Service, who let out the tornado watch in advance. The tornado warning came out just 6 minutes before this tornado touched down. So that's the kind of lead time that we have leading up to these kinds of events. All right, so let's talk about the final event, the tornadic outbreak of southern Louisiana, which occurred on February 23rd of 2016. We've already defined an outbreak. This outbreak was associated with 23 tornadoes. It's not unusual for Louisiana to get tornadoes, as we talked about 37 per year. What is unusual, however, is for Louisiana to have this big of an outbreak. Hundreds of homes were destroyed. In Laplace, over 200 homes were destroyed. The Sugar Hill Recreational Trailer Park was obliterated. 3 people died from this event, 2 in Louisiana. Schools and universities were actually closed in a, we're going to talk about that in a second. Thousands were left without power. Not sure of the actual injury count. I did check the storm reports and didn't find any injury totals. The disaster declarations were issued for several parishes, but impacts were definitely minimized by NOAA's efforts. So having a look at the storm report map, there were 7 EF0s, 3 EF1s, 2 EF2s, and 1 EF3. The 13 tornadoes pretty much occurred just east of Baton Rouge and in southeastern Louisiana and southern Mississippi. The day before the actual events, I recall the National Weather Service elevating the weather threat from slight to enhanced. This actually gave people a heads up that bad weather was on the way, and people in southern Louisiana are very accustomed to experiencing bad weather, so they took this seriously. Universities were closed after noon. Area schools were closed for the entire day. Government offices were closed. So there weren't a lot of people out and about on that day, which helped reduce the injury count and the fatality count. 2 specific photos. On the left, we see the Sugar Hill Recreational Trailer Park in Convent, Louisiana. This is where the 2 deaths occurred, and you can see total obliteration of the trailer park. On the right, we have a Gold's Gym in Prairieville, Louisiana. 2 notes about this particular photo. One, a feel-good story, and the other kind of comical. The feel-good story is that there were about 37 people in the gym, 9 of them, or maybe it was 8, I can't remember exactly, children in the daycare. No fatalities from that event at Gold's Gym and no injuries. Now the comical side is there was a gentleman working on the treadmill as this storm passed through, and even after the roof got ripped off the gym, this gentleman kept running on the treadmill to the point where the staff had to come walk up to him and say, look, we're closed. So on that note, I'm going to pass it on to Alan, who's going to talk about winter weather.
Okay, thanks for sticking with us. We're going to talk about a different type of extreme weather, and perhaps for those of you who are in the north, up in the Great Plains or in the upper Midwest, you say, ha, winter weather in the south, come on. But we do, in fact, have some impactful winter weather here, and I've included some pictures here just to kind of look at you. Of course, everyone who's ever driven in the snow or ice knows that the impact it can have on traffic. I like this picture because you've got the ice hanging here, and then, of course, a nice, beautiful natural scene. So we're going to talk a little bit about winter weather, something completely different, and a little bit about the impacts that it has here in the south. So to start off, I just want to talk a little bit about the winter temperature climatology. This is our average minimum temperature, our low temperature during the winter from December through February. And of course, some of these are downright balmy conditions. I'm from Illinois originally, and so when you see, oh, our average low is in the 40s or 30s, you go, oh, that's not even coat weather. But let me assure you that in Louisiana, where people put on coats when it's 60, this is downright Arctic for them. You'll notice the 2 coldest areas in our region, of course, are in sort of the northwest corner in the Texas and Oklahoma panhandles, and then, of course, into northern Arkansas and into Tennessee as well, which makes perfect sense, right? Arctic air coming down from the north, and those are the areas that are most likely to be impacted and most likely to be impacted for a longer period of time during the winter months. Looking at the all-time minimum low temperatures, now this map is actually smoothed out. You notice we have these nice little, these sort of gentle contours. There's a lot more variation in the actual data. It turns out that the lowest temperatures recorded in our southern region out in Tennessee in the mountains of the Appalachians, -32 up in Mountain City, Tennessee. Oklahoma's not far behind, nor is Arkansas. You move a little bit further south, Texas, the all-time low there, -23, -19 in Mississippi, and then -16 in Louisiana. Again, as they would say here, that's darn cold. And in Minnesota, you would call that a nice day. So in any case, we can get pretty cold down here, especially relative to what people are used to, and especially we consider, you know, some people don't even have heat. So just something to consider there. Looking at snowfall, you'll notice a whole swath of the region here in this orangish color where you on average receive somewhere between 1/10 and 1 inch of snow per year. Of course, that then increases as you go north, and our hot spots again are sort of in the Oklahoma and Texas Panhandle and in the mountains of Tennessee, where they do receive a pretty decent amount of snow relative to the rest of the region. Now, if you remember when you registered for the webinar, we did pose a question: what's the greatest snow total ever measured along the U.S. Gulf Coast? We gave you 4 choices: 16 inches at Shell Beach, 20 inches at Houston, 6 inches at Mobile, Alabama, and 24 inches at Rayne, Louisiana. So if you didn't remember the question, you can think about that for a minute while I talk a little bit about it. And then maybe you'll have the answer. So if we look at the all-time maximum snowfall record, again, this is smoothed out, so it sort of smooths out some of our highest totals. But again, not surprisingly, our all-time maximum snowfall records seem to be in the northern part of the region, where, of course, you just get more snow. In Louisiana, we start off with our one-day recorded maximum snow of 13 inches. In Mississippi, it's just a little more. You get up to 18 inches. 3 states, Texas, Oklahoma, and Arkansas, all had their one-day record totals of 25 inches, and then Tennessee up in the mountains, just a little more at 30 inches. But if we come back to that question, you'll say, hey, now wait a second, these are all by the Gulf Coast, and you didn't say anything about them. So it turns out that the greatest snow total ever measured along the U.S. Gulf Coast was the 24 inches at Rayne, Louisiana. And I'm going to show you where Rayne, Louisiana is in a second. But this was associated with the February 1895 snowstorm. And again, the reason that this total doesn't come up on our map before is that this was a sort of a storm total. It was more than a one-day total. And so it's a little bit of trickery on my part there to show you something a little bit different that maybe didn't help answer the question. But this February 1895 snowstorm is one for the records even still today across the South. This picture here is Canal Street after the snowstorm of 1895 in New Orleans. It may be a painting or it's a colorized picture, I don't know. But in any case, you notice the streetcars here stuck in the snow. This is actually a picture on the bottom here from Lake Charles, which is in the western part of the state. And you can just, you can't really see the face, but you can probably imagine the delight or perhaps horror expressed by this small child who may have never even seen snow, and now they've got 2 feet of it. The Fort Worth Gazette, in a story on February 15th, 1895, said, "For more than 12 hours past, snow has fallen here steadily, and tonight, evening of the 14th, the Crescent City is wrapped in a mantle of light such as she never wore before. Streetcar service was entirely suspended this afternoon." And so it made the newspaper in Texas there. And it's really a very interesting little snowstorm. This image is courtesy of one of our local TV stations. Across the state of Louisiana, again, Rayne, Louisiana is right here. 24 inches of snow, 22 in Lake Charles where that child was looking on in amazement. 14 inches as you move over here towards Lafayette, 12.5 in Baton Rouge, and a little over 8 inches in New Orleans. So this is great, 1 to 2 feet of snow across portions of Louisiana. Something, again, it's one for the record books, and it's, 2 feet of snow probably gets attention in a lot of parts of the country. It definitely gets a lot of attention down here in Louisiana. This storm did also affect portions of Texas. In Texas, near Brownsville, they had 3 to 6 inches. Galveston, right on the coast there, registered 15 inches, and Houston had 20 inches, which I also worked into that little question. So it turns out that you were sort of right if you picked Houston too. So that's okay. Houston's Main Street, you can see deep in snow. You can sort of see the ruts of the wagon wheels here. Another picture of Houston down here. A couple more pictures. This is Beaumont, Texas. You can see the cattle along the street here walking through the snow. And this is Olive, Texas, which is north of Beaumont. It's actually a ghost town now, but at the time it was a thriving little town and had a beautiful little coating of snow after this snowstorm. If we look at the weather map for February 14th, 1895, temperatures across the Gulf Coast were in the 20s, and I've highlighted here our isotherm. This is just saying that basically areas to the north of this red line were all colder than 20 degrees. Areas between this red line and this one here that's labeled 30 were all in the 20s. And so you notice temperatures along the Gulf Coast were quite cold, in the 20s. And there was a area of low pressure offshore in the Gulf, located approximately here. It doesn't show up on the map, but it is definitely there. This grayish area here depicts where the precipitation, and of course in this case snowfall was occurring. So if you have a area of low pressure that gives you that upward motion, a lift for the storm or for the snowfall, you have cold enough temperatures. Of course, we always have plenty of moisture near the Gulf, and that's the ingredients that you need for some pretty significant snows. If we look on the 15th, one day later, here's our 20-degree isotherm again. So our area all here along the Gulf is somewhere between 20 and 30 degrees. You can sort of see this area of low pressure. Now it's close enough to the Florida peninsula there that we can sort of see it on the map. And so it had progressed from the 14th. It was in this region, and it sort of moved to the east as we would expect. So this hasn't, we don't see snows like this very often down here, but anytime all you need is a low that takes this approximate track. You'll notice this huge area of high pressure, an Arctic high that had built in, which was able to push all of this cold air far enough south to bring everything together for this to happen. And again, snow can be very impactful in the south, even though it doesn't occur very often. If we look at the number of weather-related fatalities from 1975 through 2011 in the southern region, of course hurricanes are our #1 killer. Over 1,800 deaths. A large majority, as you might have guessed, occurred in Katrina. Tornadoes, over 800, almost 900 deaths. Again, the outbreak that Luigi mentioned is certainly part of it, and you can see some of these other occurrences as well. But we've had over 1,600 deaths in car crashes related to snowfall in that 6-state region over these years. And so if you put that in, it might help you kind of put it in perspective. These only occur 1 or 2 at a time when we have these snowfalls, but over time they do add up. And so I argue that it's pretty impactful for our region. And of course, if we did this tabulation for other regions, you'd probably see something pretty similar. And so that's all I have. And with that, I think we'll take questions, if I understand.
That's right, Alan. Thank you for Alan and Luigi and Barry for a great presentation there. Some very interesting stuff from your area of the country. I have a quick question, Luigi. That those tornadoes in Louisiana, are they basically nocturnal ones? Or do you guys find those rain wrapped in the middle of the night, or are those daytime tornadoes?
Or right about when you would expect a mid-afternoon, right when the convective activity was ramping up. We do sometimes get them overnight, but for that specific event, they were right in the middle of the afternoon.
Okay, thanks. So folks, if you want to type in your question, be sure to include your first name and your state, and we'll take those questions. Again, if we don't get to all of them today, we're going to ask our friends here to follow up with you via email. And I know we have Nolan Duskin with us. Nolan, do you have any burning questions here for these guys?
Well, just an observation to begin with. I pulled up the Fort Collins climate records to go with your snowstorm back in February of 1895, and I find that we had 4 nights in a row with low temperatures in the -20s while you were having that snow. So it was a widespread cold outbreak that helped create that snow situation down your way.
Yeah, absolutely. I mean, you on the weather map, you could see, and I pointed out the big high pressure there. That's that that Arctic high that really was able to push that cold air this far south. Barry, did you have something you wanted to say about it, or?
No, I was just going to thank Nolan for sending all that cold air down there.
Oh yeah. Thank you. Well, it'll give our, not that there was air conditioning in 1895 per se, but it would have given our air conditioning a break. So we'll take it.
Yeah.
And
Okay,
I'm curious how cold you get there in Baton Rouge. What's the coldest temperatures that you've experienced since you've lived there?
I think the record here is about 10 degrees. That occurred in, it was right before Christmas of 1989, and we had a real serious cold air Arctic outbreak. You know, I mean, obviously, if we're having an Arctic outbreak, so is everybody else in the Gulf South, right? And most everywhere else. But in New Orleans, I think got down to about 11. So that was a big deal. There were some problems. I know there was a giant explosion at the Exxon plant here just north of Baton Rouge, and it was because of the cold. I also arrived back here on campus shortly after Christmas, and in a couple of the classrooms I spent some time in, there was like 2 feet of water in the classroom from broken pipes. So there were serious issues all across the region from that particular event. It was a big deal. Not to mention it put a crimp in my bachelor parties. I was getting married about a week after that.
Okay, hey, we got some questions coming in. They're starting to pile up here. Let me go quickly. Rhonda's in Tennessee, and she wants you to look into your crystal ball. And do you think this winter will produce a lot of snow in Tennessee? And I don't know what part of Tennessee she's in, but
well, the NOAA forecast from Climate Prediction Center is calling for warm and dry across most of the Gulf South this winter. Now, of course, that doesn't mean we're going to miss out on some specific event, but I'd say the probability, the chances of seeing something like that is maybe a little less than it would be in even an average year. So that's about all I can tell you at this juncture.
okay. Abigail from Greeley, Colorado writes in talking about that 1895 snow event, and she's wondering, did the ocean effect this? Did ocean effect cause the snow? So, such as the Great Lakes and so forth have the Great Lakes effect.
Sure.
There you go. That's it. Can you explain the effect? Sure. Gotcha.
Yeah, that's a really interesting question, and I don't know the answer off the top of my head, but I mean, certainly it has an impact. The ocean is a very nearby source of warm, moist of warm, moist conditions, the air mass that sits out over the ocean, and so it always has an effect on the weather down here in Louisiana. But specifically, what the effect was for that storm, I don't know. Do you have any thoughts?
Well, I'm not sure exactly what's meant by this ocean effect, but I mean, clearly, for us to get snow here, we have to have significant cold air intrusion at the surface. And normally, when the fronts get to our coastline, or more specifically, when it gets to the continental shelf, a lot of times the fronts kind of stall and it gets hung up there, and we frequently get cyclogenesis along those frontal boundaries. And by virtue of that, we get this warm Gulf air, warm moist Gulf air that overrides that cold air at the surface. Basically, it's a frontal overrunning situation, and that's what produces the most significant snowstorms across Louisiana. So I don't know if that answers the question or not, but that's kind of the synoptic setup for the big snows here.
Okay, another snow question. Joanne Logan, who is our friend of ours in Tennessee, wanted to know how cold did eastern Tennessee get? Why did it get so cold in eastern Tennessee during that outbreak in 1985, January of 85? She got to minus 24 there.
In January of 1985, you said?
January 85, and I remember being in the Carolinas during that period too, and it was a tremendous cold event that had come through.
Yeah, I'm not familiar with that one.
Yeah, I'm not either.
Okay.
I don't have any specific insight, but it's not. I don't think it's unusual for the cold air associated with an Arctic high to be able to intrude that far south. And then, of course, in eastern Tennessee, you always have the terrain effects to think about as well. So, I mean, anybody who's been up in the mountains in the Smokies can vouch that it can get quite cold and sometimes unexpectedly so if you're coming from the lower terrain. So we could certainly look into that.
Yeah,
Okay.
as I'm recalling, that was one we called the toilet freezer. We had a lot of people reporting frozen toilets when they got back from their Christmas holidays.
I hate cold weather so much. I try to blank those from my memory bank, so that's why I have no recollection of that event whatsoever.
Yeah, I remember that was Super Bowl weekend back there in '85 that everybody was watching that. Okay, here's a couple others. Lyndon out of New Mexico wants to know if you could explain extreme events, and then there's a related question by James in Austin, Texas, and he wants to know separately about normal extreme events. So of the tornadoes EF0 to 5, is there a category that is average, and how many standard deviations from that to F0 and F5 lie? That's kind of a tricky question here. So why don't we go with the first one, extreme events.
Well, I'll just jump in there on that one. I mean, there's really no formal definition of an extreme event. And like there's no formal definition of what's a heavy rainfall. I mean, we kind of go back and forth on these kinds of things. When you're looking at statistical distributions, I mean, anything beyond one standard deviation, I would say, is out of the ordinary. Anything beyond maybe 2 standard deviations is getting you into the extreme range. I mean, that's a way to look at it, maybe not the only way to look at it. Kind of just depends on what application you really are trying to put forward. As for the tornadoes, Luigi, you have anything to add to that?
I don't know what the exact numbers are. We average anywhere from 1,000 to 1,200 tornadoes annually in the United States. The strong majority of those are EF0s and EF1s, and it drops exponentially as you go to EF3, EF4, EF5. So EF5s are very rare. EF0s, EF1s are very common. Those would be your typical tornadoes, if that answers the question.
Okay, Rhonda writes in, and she wants to know, do tornadoes tend to follow the same path and when there's outbreaks in the same area? Do you find that they seem to have a track that they tend to favor?
Yeah, it's not just with outbreaks, but tornadoes in general tend to move from the southwest to the northeast.
And I want to add as well, I mean, this is actually an area of ongoing research. There are some climatologically interesting areas, it seems, where tornadoes seem to follow the same sort of path. One of them, for example, and some of this may do with terrain, we're not 100% sure, but one of them, for example, runs just north of Birmingham, Alabama. That area, it was hit on April 27, 2011. It had been hit in '98, I think, and previous to that as well. And I think there are a few areas where there's some, we don't know if it's terrain considerations or if there's something else meteorologically that's going on, but there are at least a few areas in the country where it seems these very narrow belts seem to have statistically more than you would expect in terms of the number of tornadoes. So that's an area of ongoing research. If you find the answer, let us know, and we'll be happy to run with it.
Okay, Marlene writes in and wants to know, is there a correlation with sunspot activity with some of these extreme events?
No, not everybody at once here.
Yeah.
Yeah, I would say, I think I can safely speak for all three of us that none of us have really spent any time looking at sunspots and really don't have much to say on that.
Yeah, sunspots really only contribute a small fraction of change in the amount of solar energy that we get from the sun. So to try to attribute that small change to variances in the number of tornadoes or the number of extreme weather events that we get, it would just be really hard to do.
Janet from Kentucky writes in and she wants to know, is the activity in Dixie Alley increasing with apparent climate changes in the area?
Now, that's a great question. One slide that I didn't include shows the tornado reporting bias by population, and I kind of wish I did have that figure. In the early periods of tornadic reporting from the 50s to the 70s, a lot of tornadoes went unreported simply because if it didn't cause a lot of damage, there was really no reason for a farmer or someone who spotted one to actually report it. A lot of them also went undetected because they were never seen. We didn't have the kind of radar that we have now. We don't have the kind of trained storm spotters that we have today. So if you look at the numbers, yeah, there's more tornadoes being reported, say, now than there were 30, 40 years ago, but a lot of that is attributed or attributable to the fact that we have much better equipment to identify them. In fact, even if radar doesn't detect one, we could go back and look at satellite imagery and see tornado paths carved out in the landscape and then go in and survey that. So almost no tornadoes go undetected nowadays. So it's really hard to answer that question because it's very difficult because of this reporting bias to determine whether tornadoes are increasing because we're better at spotting them and detecting them, or if it's because of climate change.
You know, there's a question here from Travis in Minnesota. He was wondering, very similar to that, what you just answered there, what has changed about the climate in Dallas? He said 60s and 70s, there were rarely any tornadoes near Dallas, almost never any snowfall, but now there are, and why? And I think you guys kind of hit that right on the head with the better detection of that stuff at this point, unless you want to add to that.
No, just briefly, well, yes, I guess, but just to briefly say, you know, I think there's a lot more emphasis on collecting these sorts of information by the Weather Service. It's very rare to have any sort of thunderstorm that could produce a tornado and not have at least one storm chaser out there. There are guys who chase 365 days a year, it seems. So, you know, as Luigi said, we're better at detecting and recording some of these events, especially the ones that are sort of on the smaller side and maybe would not have been recorded before. So I think that's part of it, absolutely.
And folks, for you folks watching or listening to the webinar, we're going to put the Southern Regional Climate Center link to their website on our page, CoCoRaHS page there for this webinar, so you can look at all the products and stuff they have to find out more about what's going on in that region of the country. Well, we've got one last question. Yeah, go ahead.
I would ask you to put the SCIP website on there too, if you don't mind. We have some links to some extreme event information as well.
SCIP will go right next to it. I'll make sure I do that. And here's the last question of the day. I kind of saved this one. I don't think we have any, what do I want to say, data on this, but a gentleman here, Thomas, writes in, and he says he's seen the movie Christmas Vacation, or I mean the Christmas Story, and how many kids get their tongues stuck on metal poles, and can that really happen? And I know you guys aren't in the medical field, so I'll just throw that one out there if anybody wants to take a crack at it. That
happened to Alan. What are you talking about?
Yeah, I have it right now. No. I think, you know, this is, I have done a little Googling when I was not, you know, working diligently on other projects about this. You know, theoretically, I think if you look at a pole and it's cold enough, you should theoretically get stuck, but I don't think to the extent that it was depicted in the movie, because typically all you'd have to do is just kind of blow on the hot air that's coming out, and you would thaw out. And no, but Luigi's shaking his head no.
I would disagree.
He's from Canada, though. This is a whole other thing.
This is a whole other issue because it is actually colder where I grew up in central Canada. You get your tongue stuck on that pole, and you basically either have to get someone to pour really hot water on it and then rip your tongue off of it, or you could just try to rip your tongue off, but you will leave a lot of skin on that pole. It is brutal.
We don't recommend it, I think, is what it boils down to.
Stay away from the cold pole.
Yeah, absolutely. Yeah. Don't go anywhere near him.
Keep your tongue to yourself.
Keep your tongue to yourself.
And actually, Emily from Wisconsin just typed in and says, yes, it has happened to me. She grew up in Wisconsin and had to try it as a kid. and I think she's probably still stuck on the pole now. She didn't say anything. But,
well, at least you have internet out there, I guess.
That's true.
So.
That's true. Yeah, you can just wire it right in. So if you didn't get anything else out of this webinar today, don't lick any cold poles when you're out there in the winter.
That's the moral to the story
today.
That's
sound advice.
Yeah, I knew you guys would be right on top of that. Very good. Well, gentlemen, it's been a pleasure to have you as part of our series. Good friends of ours, these guys. Great guys. They know their stuff. And really, thank you for taking the time out of your day to kind of be with us today and answer these. So we're going to kind of wind it up with that. And
well, I'd say,
yeah,
Nolan, but especially thanks to the people tuning in. We really appreciate it.
Yes, thank you.
And Henry and Nolan had to listen.
We did. Hey, well, folks out there, mark your calendars and please join us for our next webinar. That's going to be number 53 while we're really racking these up. That's Thursday, October 20th. So a little less than a month, about 3 weeks away. Matt Kelsch and Greg Bird of Comet, the educational program out of Boulder, Colorado, will be with us at that time, and they're going to it's some really interesting weather lessons and so forth that are free and available to the public. They'll go all over that for you. It should be another great webinar, so be sure to follow up and register for that. We'll have the registration up there shortly. And again, this one today is going to be archived, so if you want to go back, we'll also get a copy of their PowerPoint slides. You can click through those much more slowly if you like. And again, if you have any questions, these guys are always glad to answer them for you. And finally, when you're signing off today, please take the survey that's going to pop up on your screen here shortly. So until middle of October, coming up shortly, this is Henry Regis for the rest of our CoCoRaHS headquarters. What did I say that funny? CoCoRaHS, there we go. A lot of people have trouble pronouncing that. CoCoRaHS headquarters team saying so long for now and have a great afternoon.